Welcome to your third video in Chapter 10. This video deals with not the arithmetic sequence, but something called a geometric sequence. And I get the sizing right here. It's on page 608 in your book. A geometric sequence is a sequence whose consecutive terms have a ratio. So you're not adding or subtracting a certain value to get to the next number, but you're multiplying by a ratio. Let's look at an example. The best way to explain this is just to show you. I'd like you to determine the common ratio for these next three terms. So the first term is 12, second term is 36, 108, and then 324, etc. And I'd like to know what the ratio is. So ratio meaning a relationship of fractions. So if and you can look at this and you can say, oh, well, Miss Reams, you multiply by 3. Yes. If I take 36 and I divide it by 12, I'm going to get 3. A positive 3. I'm increasing here. So if I take 108, is that true? Does that hold true? Is that the same ratio? Yes, I get 3. And likewise, if I take 324 and I divide it by 108, do I get 3? Yes. Therefore, 3 is my ratio. Okay? Now, if I want to know the next three terms, then you're going to take 324 and you're going to multiply by 3. Well, that gives you 972. You take 972 times 3, and you're going to get 2,916. And you take that value times 3, and you're going to get 8748. And that goes on, right? But I only asked for the next three terms, so that is what you would tell me. Okay? You would give me those three terms. And you would tell me that the ratio is 3. Ratio is 3. Now, I would like to practice with this type of sequence to develop a recursive formula. Now, when you do that, as you remember from the first lesson, 10.1, when you have a recursive formula, I have to give you the first term because you use that in the next term, and then subsequently you use the second term in the third term, right? It's recursive, kind of spins back on itself. That's what the a sub n minus 1 is, the previous term. So if you have, let's look at this sequence that we just did. If I say the first term was 12, the second term is the first term times the ratio, which was 36. Okay. Then if I want to know the third term, I would take the third term would be the first term times the ratio again. Is that true? To get to this third term of 108, is that 12 times 3 times 3? Yes, it is. Okay. Let's try it again. The fourth term, the 324, that's equal to 12 times 3 times 3 times 3. Well, if you notice, the number of r's here is 1 less than the term. So for the second term, we only had to multiply the first term times 1r. To get the third term, we multiplied by r squared. To get to the fourth term, we multiplied by r cubed. So we can state explicitly that to get this sequence, you take the first term times the ratio, and then you would take the n value of whatever term you want minus 1. So you would have that many r's, r to that power, in other words. Now it's very important that you keep this separate. So let's get another color here. Okay, this is the explicit form of this sequence. Now notice you use the first term, and then you're multiplying by the ratio to a power here. Now notice, whatever term you want, you're going to have n minus 1. So you need to know n, and you need to know the ratio. Now let's come and look at the recursive formula. That's this one. You have to be given the first term, and then you have the previous term, the n minus 1, times your ratio. That's what we did here. We were given 12, and then to get the next term, it was going to be 12 times 3. To get the next term, we used the 36 times 3 to get 108. That's recursive. Okay? But there are times when you can get either formula for a sequence. And I just happen to have an example. Let's look at one. So I'm going to give you this sequence of 2, 25, 312.5. And I would like you to give me the recursive formula and the explicit formula. So let me slide this down just a little bit, because we need to know recursively, you've got to tell me what the first term is. Okay? So I know that the first term here is 2. Okay, the next part, I have to multiply the next term by r. Well, I don't know what r is yet. I have to calculate that. So we're going to take 25, just like we did in example 1. 25 divided by 2 is 12.5. You can have a decimal for a ratio, that's fine. Let's test it though. Let's test this one. All right, 312.5 divided by 25. What does that give me? Well, it just so happens it's 12.5. That is our R. Okay? So for the recursive formula, you're going to have this value, which is the previous term, times the ratio. So here we have the first term, we're given a sub 1, and then to get a sub n, that equals the ratio times that term of a n sub 1, which is the previous term. So this is 12.5 times the term a n sub 1. That is the recursive formula. Again, you're given the first term, then you would plug that in. Then you would plug in the second term, etc. Explicitly, you are going to take the first term, so any value in this sequence can be achieved by taking the first term, which is 2, times your ratio, 12.5, to the n minus 1 power. That would be the explicit formula. Let's box these up. So on some of your assignment today, you will be asked to find the recursive formula for this sequence and the explicit formula. All right? Let's look at example 3. I'd like you to find a specific number in the sequence. I want you to find the 12th term of this sequence if the third term is 32 and r is negative 4. All right, well that's okay. I can do that, but I'm missing something. Okay, you need something else. What you need is the first term, right? Because look back up at this formula right here. Fine, you want me to find a sub 12. I'm going to have 12 here. I'm going to have 12 here. Right? Here we go. So a sub 12 is going to equal the first term times r which is negative 4, to the 12 minus 1. All right, well, I can do negative 4 to the 11th power. I can figure that out. I don't know the 12th term yet, but I can't plug it in because I don't know the first term. So we have to find that, okay? We have to find a sub 1. So what we're going to do is use what we have. We have the third term. We have the r. We can use that to get the first term. So we're going to again use this formula right here. We have the third term and we have the r. Look at what the unknowns are. You have this term that you don't know, you have the first term, you have the r, and you have the n depending upon what term you're trying to find. So here, if we have the third term and we want to find the first term, that would be r of 3 minus 1. Well, let's plug in what we know. Right? We know that this is 32 because it tells me in the problem. I know that a sub 1, well, I don't know a sub 1, but I do know r is negative 4, and that's going to be squared. Negative 4 squared is 16. 16 into 32 is 2. So we got our a sub 1. We got the first term. Now you're going to take that and you're going to plug that in over here for this term right there. Okay. Here we go. So that equals 2 times negative 4 to the 11th power. And you can just crank that out on your calculator, and I'll write out this value because it's very, very small. 94304. And you double that, and the 12th term is 88. So negative 8,388,608. Woo, let me move it up there. There you go. All right, so sometimes your problems are going to require you to do a little bit of research first with the value that you're given. Okay? Now I want to talk a little bit about something called a geometric mean. Let me set this up for us. You can determine missing terms, which are called geometric means, between known terms if you have a known geometric sequence. So I have to tell you that you have a geometric sequence before you can find geometric means. That's kind of self-explanatory. But it's not that hard, but you have to understand what you're doing. Let's look at an example. If I'd like to determine two geometric means for a given non-consecutive terms of negative 4 and 13.5, that means that you have negative 4, you have another term, you have another term, and then you have the 13.5. So you're trying to find two missing terms between these known two terms. So in that sequence right there, you have the first term. You have the fourth term. So you can set that up knowing that n is going to be 4 because you've got 4 terms, and you can use what values you know. For example, if you have the fourth term, think about your equation, then that would equal to the first term times r, and then you take this difference, to the 4 minus 1. Well, if you look at this, you know the fourth term, you know the first term. We don't know r. but we can calculate it if we know everything else, right? So this is 13.5, this is -4, and this is times r to the third power. So you divide by -4, both sides divide by -4, you find that you have -3.375 equals r cubed. Well, how are you going to get r? Yes, you're going to take the cube root, and you can do that on your calculator. And you see that r is equal to -1.5. Great, now I know what r is. You come back over here and you can just figure out what the next term is. Because if that's r, I'm going to come over here and that next term is going to be -4 times -1.5. That equals 6. So that's 6. Now to get the next term, I'm going to take 6 times -1.5, and I'm going to get -9. Now it's always a good idea to check, just to make sure you're doing the right thing. Take -9 and multiply by -1.5. Make sure that you get the next value so that you make sure you did it right. So if I want the two geometric means, it would be 6 and -9. Now, when you come back in the second video, we're going to talk about sums of the geometric series, and we will have a couple formulas to learn in the second video. Thank you. See you then.